So, circles. That was our very first word. As you're doing this vocab, if you want to get some markers out and you want to alternate colors and do a different color for each word, and then also we're going to be adding things to the picture. The circles on the right side, we're going to add marking. So, our very first word is the name of this unit. This is the circle unit. A circle is the set of all points on a plane at a set distance from a given point, which is the center in the plane. How do you think you name a circle? How do you call one circle different from another one? How do you name a circle? I'm glad we went over this. So some people said midpoint, some people said middle. The answer is center. It is a specific word. So yeah, we name a circle based off of its center. So a circle only has one center, right? Circle can only have one center. So therefore, that is the name of our circle every time. We're going to name it with a capital letter, and you need to write this in your notes. This is the notation. How do you name a circle? So you could call it like circle P if the center's name was P, or circle B. That's how you name a circle. Circle symbol, capital letter. What is the next word? Old news, old news. Radius, of course. The radius is a segment from the center of a circle to the point on a circle. So go ahead and write the word radius and then add radius AB to your picture. How many radii, radii by the way is plural for radius, you put two I's on it. How many radii does a circle have? Of course, infinite. Let's name the endpoints of a radius. So we have a radius. What do its endpoints have to be? What's one of them? The center. So one of its endpoints has to be, oops, I forgot to put my E. And what does the other endpoint have to be? What needs to be true about the other endpoint? On, good. And you don't even have to call it the circumference. You call it the circle. On the circle. Because this set of points is the circle. It's not the stuff inside. It's not that. The circle is actually the set of points right here, that collection of points, okay? So one endpoint is the center, one endpoint is on the circle. Can you have radii in the same circle that are different lengths? Absolutely not. So once you find the length of the radius, that's going to be the length of the radius throughout the whole circle the whole time. Okay, next word. Distance around the circle is, of course, circumference. We already knew that. And the formula is 2 pi r. Won't stay here very long because we already knew this, and we can move on to some new words. Okay. Up next, 2 points on a circle and the continuous unbroken part of the circle between the 2 points. 2 points on a circle and the continuous unbroken part of the circle between the points. Very good. That is called an arc. Just a plain old arc. What's really important is the notation here. How do we name a segment different from an arc, right? So if I wrote this, that'd be segment BC. If I wrote this, that would be line BC. Now, new, if I write that, that is arc BC. So that's how we communicate to each other. We wanted that to be an arc, not a segment. So an arc is always going to be curved. It's a portion of the circumference, kind of, portion of the circle. So what type of arcs do you think there are? A good analogy for this is we have angles. Then we can classify angles. Acute, obtuse, right. Very good, Ralph. So we're going to have major, we're going to have minor. What's the other one going to be? So acute would be the minor if we're trying to do an analogy. Obtuse would be major. What would a right angle, what would that be? Right in the middle. So acute is less than half. Mediocre. Acute is less than half. Minor is less than half. Major is more than half. What would be exactly half? You got it, a semicircle. Let's go over these one at a time. Semicircle. An arc of a circle whose endpoints are the endpoints of a diameter. So if I put BC like this, that is the diameter. If I put BC like this, that is a semicircle. Do you see how important notation is? Just changing that one little symbol completely changed what I was talking about. So Kendra asked why D is on the picture. So if I just said, like I did down here, if I just said arc BC, I get this question a million times, which arc am I talking about? If I just say arc BC, am I talking about the green one or am I talking about the red one? So adding another letter in there tells us which arc you're talking about. It's the way it goes, even though they don't travel anywhere, but it tells you, it gives you a point that anchors your arc. So I know I'm talking about the green one, not the pink one. Okay? Our next one, an arc whose length is less than half of the circle, and we name it with 2 points. We already talked about that. It is called a minor arc. So BC, if you use 2 letters, if you only use 2 letters, it is a minor arc. It could also be a semicircle, but it is either a minor arc or a semicircle. 2 letters, minor arc. So you never, ever, ever have to ask me, if I say arc BC, and you're like, well, which way do I go? Do I go this way or do I go this way? You never need to ask me, because if it's 2 letters, you always go the shortest way you can get there. Because you know 2 letters flags that it's a minor arc, and therefore it's less than half. And our real world example is this leftover piece of pie. This crust right here is a perfect example of a minor arc. Leftover pie. Okay, the opposite of minor, we talked about this, is of course major arc. An arc of a circle whose length is more than half of the circle. We name it with 3 points. So you go in the order when you're trying to like highlight the arc or shade it. You go in the order that the notation tells you to go. So you start at B. Which way do I go? Which way do I go? Well, I have to go to C next. So I know I have to go this way. B, go through C and end at D. Have you ever been in Google Maps and you're like, okay, I know I need to get from here to, let's say, Baton Rouge, Louisiana, but I want to stop somewhere and get lunch, and I'm going to stop like in, I don't know, Beaumont or whatever. That wouldn't be very long to wait. But anyways, so you have a start, you have an end, but then you want to take a pit stop. You want to have like somewhere that you stop along the way. So anyways, that's kind of like, I want to start at B, I want to end at D, but I want to make sure I go through C because I'm really hungry and I want to get lunch. A very good example of a major arc is the letter C. The letter C, to do a good letter C, you need to go more than halfway around the circle, making it a perfect major arc. Okay, new word alert. New word alert. Go ahead and read the definition to yourself. Go ahead and draw the picture, and then we'll talk about what this word is. All right, a segment whose endpoints are on the circle. This is a new word. That word is chord. That word might be familiar to you if you're into music. A chord. So a chord is any segment whose endpoints are on the circle. On the circle. They can't be one on the circle and one just hanging out. It can't be that. It can't be one at the center and one on the circle because that's a radius. The endpoints have to be on the circle. Always, sometimes, or never. A diameter is a chord. What do you think? Always, sometimes, never. A diameter is a chord. Let's look at those definitions. a chord has to have segments it has to be a segment, a diameter is a segment, check. Its endpoints need to be on the circle. Is a diameter's endpoints, are they always, sometimes or never, on the circle? Always. The answer is always, yep. When will a chord be a diameter? Tell me what would have to happen for a chord to be a diameter. Exactly. When a chord would be a diameter when that chord goes through the center. And there we go. A chord that contains the center of the circle is a diameter. A chord that contains the center of the circle is the diameter. When you order pizza, if you order a 12-inch pizza or a 14-inch pizza, they are measuring the diameter of the pizza. They're not measuring the circumference. They're measuring not a chord. It has to go through the center for them to say that that pizza is really a large, it's really a 14-inch or whatever. A diameter is the absolute longest chord you can absolutely have. You cannot draw a chord that's longer than the diameter. It's as long as it gets. Let's move on. A line that intersects the circle in 2 points. It contains a chord. So go back and look at your definition of chord and then look at this definition. How are these alike and different? Okay, very good. You said that the difference was a chord is a line segment and this word that we don't know yet is a line. So that's the only difference. Take a chord, put arrows on it, and you get this word. The answer is, this word is secant. Everyone practice saying that out loud. Secant. Literally the only difference is a chord has endpoints and a secant does not. A lot of people get chord and secant mixed up. So let me tell you a little trick. Oops. Well, we'll just pretend that it was BD. So this is our chord. And this is our... Now, it doesn't beat it by much. It's kind of sad. It doesn't beat it. It only beats it by 1. But a secant, that word is longer than chord. So a secant is longer than a chord. So a chord has a beginning and an end, and a secant goes on forever. People get these words mixed up a lot. Another way some people like to remember the difference is secant, like I can't see, and a secant goes on forever, so I can't see the end of it. I can't see the end of it. Ha ha ha. Okay. Here we are. Next one. Yes, it is a line that intersects the circle at a single point. This is so important. A line that intersects the circle at a single point. And that line is called the tangent line. The tangent line. So just like a line can intersect a circle at just one point, so can a plane intersect a cylinder at just one line. It's kind of the same thing. Tangent line. A line that intersects a circle once and only once. It is a line, so it does have arrows and it does go on forever. So, did you see that word always, Kendra? Yes. It is always perpendicular to the radius. So that right angle is not just a coincidence. A tangent line, and we'll learn this theorem later, I can even prove it to you. A tangent line is always perpendicular to one radius of the circle. Wherever the radius intersects the tangent line, because they only intersect one time, that is a right angle. So C is the vertex of the right angle. Yes, it has to be a right angle. Okay. This next word is very, the word is very descriptive of what the object actually is. What is the point? By the way, I didn't change the picture at all. The point where the tangent line intersects the circle is called the point of tangency. The word describes exactly what it does. So in this one, I drew the same picture, but I want you to zoom in on or highlight. This one is C. C is the point of tangency. It's the point where the tangent line hits the circle. And C, like I was saying on the last slide, C is the vertex of the right angle that's created. So C is the vertex of the right angle that's created. Next one. Ooh, now we're moving into angles. So lines we're done with, segments we're done with, arcs we're done with. Now we're going to talk about a couple angles. An angle whose vertex, keyword, is the center of circle. And then its side is going to contain the radii of the circle. So, good. If the vertex is on the center, we're going to call it a central angle. If the vertex is on the center, we are going to call it a central angle. A good example of a central angle is the hands of a clock always form a central angle. I guess unless it's 12 o'clock, right? That'd be an angle with a degree of 0, which, is that really an angle? No. Okay, I had a question. Are segment BA and AC congruent? What do you think, guys? And if we were trying to explain that to someone, back up our logic, why are they congruent? Well, it's because they're both radii. And every radius, all radii in the same circle are congruent. That's probably a theorem. Okay, because math. Okay, that's all I have now. Let's do the next word. Here's another angle. This angle, though, look at its vertex. You always, when you're trying to name these angles, you always say, where is the vertex? Where is the vertex? This angle's, okay, so this angle's vertex is on the circle. This angle's vertex is on the circle. So, the name of this one, as I choke, is called an inscribed angle. Inscribed angle. We've heard this word before when we heard inscribed and circumscribed. So like when we inscribe a quadrilateral, trying not to make it a square, then we have 1, 2, 3, 4 inscribed angles when we do that. I have more food examples apparently. Neil, we haven't learned the theorems about it yet. Stop giving it away. A fortune cookie, kind of, if it was a circle, then this would be the inscribed angle. I need someone to name me another inscribed angle, not angle BDC. Name another inscribed angle using my picture. Okay, let's talk about that. Someone said DBA, and I'm going to have to say no to that, because DBA would not be an inscribed angle. You wouldn't want to name it A, because notice, well, don't notice, it's not in the definition. I see that now. It's not in the definition. We need to make this definition better. The angle, the vertex has to lie on the circle, but the other points have to also be on the circle. You have to keep going all the way here. And yes, I know that an angle is made up of rays, and rays go on forever, so it doesn't stop at A, but we wouldn't know where it hit the circle if all we call it is DBA. So anyways, I would say if you needed to name another inscribed angle, DBC would be a great choice. Or what else did y'all say? I think that's all. Yeah, and DCB. We did another color. So you're really just naming the different angles of that triangle, right? So angle D, that one was already named, so you could name angle B and angle C. Yeah, okay. Almost done. This one is not very enlightening. Two circles with congruent radii are called congruent circles. But the cool thing about that is that if you're trying to determine if two circles are congruent, do you have to check all sorts of things? Side angle, side, 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 side. Do you have to check all sorts of things? No. All you do is say, hey, yes or no. The radii are congruent or they're not. So that's pretty cool. Good. They are similar circles, but that's not the vocab word. That would really be appropriate after congruent, wouldn't it? But it's not. Yes, Neil. They're actually called concentric circles. Concentric circles are coplanar circles that have the same center. A dartboard is concentric circles. If you skip rocks in the water, or you just let a rock plop or anything plop into the water, it creates a ripple effect, and those are concentric circles because they have the same center. By the way, all circles are similar to each other when y'all were saying that earlier. So We don't need to define similar ones because they're all similar. The Target logo, that's similar circles. So, all right, let's go through and use our brand new vocab and see if we can name these things. Pay attention to the notation. This is saying segment AC. Segment AC is a chord, but it's more than that. It's a diameter. Arc BC. Arc BC. Don't really even have to look at my picture. Because it's named with 2 letters, I know it's a minor arc. Arc ABC. This one I do need to look at the picture because that one ended up being not just a major arc, but a semicircle. Line CR. It's very important that you see that that has arrows. Line CR touches the circle 1 time. It is a tangent line. Point C is, I'm not even going to write it out, point of tangency. And then this one says segment AB. Segment AB. So don't use the whole line. We only want the segment. And segment AB is chord. You spell chord with a CH, not a CO.